add two numbers. Let's get started. Since it's a medium question, we're gonna start with 25 minutes. So easy, 15 minutes, medium, 25 minutes, hard, 35 minutes. Okay. So, right, let's not waste time. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reversed order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. Okay. So basically we're giving two linked lists and we should add them up and either we create a new linked list based off of the sum. Okay, so we have 2, 5 and 4, 6. So 2, 5, 7, 4, 6 is 10, but we will add the 1 to 3 plus 4, which is 8. So we have one array, 2, 4, 3, 5, 4, 6. This is the example. And the other example is 0, 0, 0. And for example, we have 9, 9, 9, 9, 9, 9, 9, 9, 9. And then we should add it from the end. So basically, we should read it from right to left, right? So it's 9. This is 900,000, 90, and this is 9,000. And then we add them up. 9 plus 9 is 8. And then we add 1 to the next digit all the way to the end. The number of nodes in each linked list is in the range 1 to 100. So we don't need to worry about linked list being too long. So 0 less than no value less than 9. Okay, so we don't need to check if the value in the node is larger than 9. So it is guaranteed that the list represents a number that does not have leading zeros. Okay, so alright, let's see what the code they provide us. I'll just put it here. I really don't like the new UI. Got it. So definition for linked list, we have a linked list node that can What's wrong? Sorry, it's some technical issue. Okay. I don't know why my the movie recording just froze. Anyways, so definition for singly linked list. Public class. Okay, we have a value and a list node in the definition. In the list node structure, and then we have different initialization constructors. Okay, and then the method will be called add two numbers, which takes in list node, or it's optional, and list node 2. List 2 is also optional. Okay, it took us 5 minutes to. Oh wait. Sorry. It took us 5 minutes to read a question. It's a bit too long. So, I think adding up the notes one by one is relatively easy. I think the difficulty of this question is that the lists might have different lengths. So once we iterate through the end of either one of the lists, we need to keep doing the addition for the other list, right? And the condition, the addition will be continued until both lists are calculated. Okay, so first of all, we need to create a new linked list, and we will need to have a number that keeps track of whether we have carried a 1 from the previous calculation of the 2 digits. Okay, so first of all, let's call it 10, which is 0, and we need to create a new dummy linked list in order to return the result. So I guess we can call it let dummy is equal to list node, and we will have, let's just call it result, and we will have another dummy that is pointing to result.next, result.next, which is a optional, will be pointed to dummy. Okay, so this dummy will be iterate through itself in order to generate the result, the ring list we want. Okay, so we're gonna start iterating both lists. So while L1 is not equal to null and L2 is not equal to null, we will retrieve the value and add them up. So int sum is equal to L1. So because L1 is an optional, so we need to force unwrap it, because it's safe to force unwrap now because we obviously know that they're both not null. So force unwrap value plus L2 force unwrap dot value plus 10. Okay, and then 10 will see if I don't know if you can do this but I don't think you can do this. 10 divide itself by 10 to see if we have to carry 1 for the next digit, and sum will be equal to sum mode 10. Okay, so we got the digit for this new list node. So we'll be dummy is equal to list node create sum, and dummy is equal to dummy dot next. Okay, we move forward to the next. I can't even scroll down. Okay, I guess I'll put it here. Okay, so we'll create a new list node, and dummy move up to the next dummy. So let's check if they both match the type. This is let's know is assigned to dummy. Dummy is optional. Okay, all right. So L1 is also L1 dot next is equal to L2 equal to L2 dot next. Okay. So we'll keep iterating through both lists, and then once this loop gets out, we'll also do a check. We'll continue this iteration on the list that hasn't ended yet. So, but first we need to find a list that hasn't ended. So it will be I guess we need to create a new variable var let's go with temp. It's equal to, let's see if L1 is not equal to null, then we will definitely assign L1 to temp, or else we'll assign L2. Okay, so now while temp is not equal to null, we'll pretty much do the same calculation. Init sum equal to temp force unwrap value plus 10, and 10 will equal to 10 divided by 10. So we retrieve the tens like we did in the previous step, plus module 10, and same thing, dummy equal to list node sum dummy is equal to dummy next, and then L1 temp will be equal to temp dot next. So we have iterate so we have iterated both this. Now we need to see if 10 is still there. So if 10 is not equal to 0, then dummy is equal to this node 10. It's actually just 1, but I guess it doesn't matter. Okay, so and then at the end we'll return result dot next, because we have result that is keeping track of the head of the result linked list. Okay, so let's see how much time we have. Well, 11 minutes. It took us 10 minutes. So do you want to go through this? Let's go through it by eyes. So while L1 and L2 are not the end, we'll add L1, L2, and then 10. Oh no, it should be sum divided by 10. So 10 we'll retrieve the sum will be equal to this, then create a list node and move up to the next dummy, 1 move up, L2 move up, and then var 10 temp is equal to, if L1 is not null, then assign L1, otherwise assign L2. Well, temp is not equal to null, Then we'll have value plus 10. Okay. Oh no, we made a mistake here again. It should be sum. 10 is sum divided by 10, and then dummy is equal to list node. Move up to the next dummy. Move up to the next temp. If 10 is not equal to 0, then we'll create a dummy, a new list node. Not create a dummy, we'll create a new list node, and then we return the okay. Looks pretty good. Let's see. Conservative Wait, why am I doing an int? This is why you have too much. This is the reason. This is why you can see I have too much influence from Java. Like int. Oh my god, this is like crazy. This is what you get from programming from a Java background. Alright, so let's see, run code. Listen, I must be unwrapped to refer to number next. Okay, so we can force unwrap here because we know that dummy is not null. Will we have to unwrap here? Yes, we can unwrap here. Yes, we can unwrap here. We can unwrap here. We can unwrap here. Okay. Cannot assign value. L is that let constant. Oh, so L1 is let constant. Okay, so we need to also create a new reference for L1 because they are constant. So this is where it's different from Java, because Java you can just directly modify it, but it's fine. So we'll have to oh shit. Okay, this should be good. Wrong answer? Output is a null. So output is a null, which means that this is empty. So result.next it's dummy, and so this doesn't look bad. Temp is equal to, if it's not equal to null. So How come it could be, it's null? Okay. So the entire list, it's empty. So it didn't add anything? Dummy is equal to list node. Can I print dummy dot var? Oh yeah, I should print out the dummy here. Wait. So okay. So here, okay. Let me see if. So first of all, we need to make sure. I mean, we're pretty sure that dummy it's initialized with this node. So I need to make sure that we didn't lose anything. So result dot next dot value. Unexpected from null. So result dot next is null. So result.next value is null. But it doesn't make sense because result.next. Wait. So result.next is no fuck. 152 minutes? Result.next. I don't understand. Oh no. Wait. What's wrong with this? I mean, so dummy.next is what the fuck? Oh my god, I failed this challenge. see. Okay, so this is now, which means there's something wrong with the result. So result.next is now. Even though dummy has a list node on it. So oh wait, maybe. Okay, so wait, maybe it should be like this. Dummy is this, and then how can you assign a nail to a? Okay, this is stupid. Okay, okay, so dummy dot next is equal to list node, right? Dummy dot next. You shouldn't assign a nail to a dummy, right? Okay, so dummy dot next is equal to list node, and then dummy is equal to dummy this, and then moving up for L1 and L2 is fine, and this one here you need to also do some dummy dot next. It's equal to this, and then dummy dot next is equal to dummy, and then that's it. Okay. The option must be unwrapped to a value of type list node. Oh. Okay, so but once I unwrap it, it's gonna become now, right? Oh well, I mean, yeah, you can force unwrap it because we for sure know that this .NET it's safe. I guess we need to unwrap it here too. Cannot force unwrap value of non-optional type. Okay, so dummy should be, the exclamation mark should be removed because dummy is not optional. So we should remove this and force unwrap. But then temp, I mean, once we force unwrap this, we might end up getting a next. Sorry, I might end up getting a nail. We don't need to force unwrap this. Just need to. 10 must be force unwrapped, but it's safe to do so because we know that it's not no. Okay, accept it. This is taking much longer than I should have. Let's see. It took me, wow, 30 minutes. Alright, let's submit it. Wrong answer. Expected. There's one. Oh, sorry. There should be a dot next. Stupid. Success. Faster than 5.63. Really? I'm that slow? Alright, 5.63. Okay. Wow. God damn it. I don't know why it's so slow. Yeah, if you're a Swift expert, I'm pretty sure, I mean, there's nothing wrong with my algorithm. The problem is this is stupid. This is stupid. You should have a dummy pointed to result, and then, I don't know, because if you point now to a dummy, then you lose the reference. I don't know how can I forget that. I mean, I guess I haven't been coding Lico for a while, so I completely forget this. So you need to have a solid reference pointing to the next pointer, right? This is what you learn. And I guess I learned a lot from the force unwrapping too. You know, see the force unwrapped and the force unwrapped here. Okay. Well, it was a failure this time. I'm pretty ashamed of this. And anyways, if you made it this far, thanks for your attention, and I hope you enjoy this video, and I'll see you next time. Bye bye.